Hey everyone, DevSecops on Microsoft Azure. We're going to split this session into two parts. So first of all, we're going to look at some of the fundamentals of DevSecops, what it means, why we're doing DevSecops, and how to achieve and implement DevSecops in your organization from a team and culture perspective. Then we're going to look at some of the tooling in Microsoft Azure that you can natively use to enable the scenarios that we discussed earlier within your environment. So first of all, I obviously just want to say thank you to the sponsors. So Script Runner, DQ Global, Proximo Free, Redspire, Agilicis, and last but not least, Hitachi Solutions. Also want to say thank you to all of the event organisers and volunteers that have helped put this amazing event together. And obviously to all of you as well for giving up some of your time to attend all of these great sessions. So my name is Martyn. I work for an organisation called Insono, who are a cloud managed service provider. I'm a principal consultant there, so I work day to day with clients on DevOps scenarios and cloud native technology. You can find me at the Twitter handle there, Mr. Coops. I'm also a Microsoft MVP in Azure as well. And I'm also a DevOps ambassador with the DevOps Institute as well. So let's get into the session. So first of all, I want to just play back some statistics. I think it's important to back up why we do what we do with data. And in this presentation, I want to talk to you about a little bit of some of the information that we can get from some of the industry reports out there as to why security is so important. Hopefully it's fairly obvious to a lot of people, but there's a couple of things that I want to highlight. So first things first, you can obviously see this is from the 2019 Data Breach Investigations report from Verizon. So they've said 69% of attacks that they surveyed were responsible by outsiders. So it was the outsiders that were responsible for committing those attacks and gaining access to systems. Quite a long way behind there is 39% of these breaches were organised criminal groups looking to extort businesses or steal personal information to then sell on, etc., etc. And then one of the things that I was quite surprised by actually the first time I saw this report is that 34% were because of internal bad actors. Now, that's people within your organisation. They're not people outside of your firewall or outside of any controls on your network. They are inside of that boundary. And that's an interesting angle to look at, and that's an interesting prospect when it comes to protecting your network and protecting your data and protecting your clients. Next down with 23% was state-affiliated actors. So these are governments and state-sponsored hackers that are trying to infiltrate your systems. Quite a long way behind there then at 5% are multiple partners that you might work with within your organization, and then 2% accounts for single partners within there. So I want to talk about some of the concepts of DevSecops. Okay, so one of the biggest concepts is around shift left. So shift left is really important because when it comes to security, the more people we have involved in security, the better we can protect our applications, our data, and our clients, and ultimately ourselves and our organization. Now, shifting left is a concept that empowers people to do what other teams would do without the level of expertise, but still have the empowerment to be able to highlight and flag up issues without the fear of recrimination by those teams. So security thinking in this scenario starts at the furthest possible stage left that comes ultimately in design. So we talk about security by design a lot as well. And that's really where it comes in. But also operationally as well, shift left from an operations perspective is our operations team highlighting some of these things that are happening and coming up with creative ways to come and fix them and highlight them back to the developers and information security teams. Next one is around building with confidence. So certainly applications I've worked with recently, they pretty much all contain some third-party code. So if you're introducing anything from NuGet repositories or any other package management repository, some of them are even open source as well. They're third-party pieces of code. So when it comes to securing your software supply chain, that's actually a challenge, being able to control and secure that supply chain when you're using third parties, because you're pulling in code that you have no idea what is contained within those binaries. So that can create an interesting challenge for security teams as well. Delivery of a secure platform. Specifically on Azure, you can leverage a number of different security services. Security is a real strong point of Microsoft when it comes to the cloud platform. You can make your platform very, very secure and extremely safe with different types of blueprints, different levels of access control, firewalls, encryption tools, key management, and various other pieces of managed services. The ability to use Key Vault to store all of those keys, the ability to run code securely and things like Kubernetes services are all tools that make for a secure platform, and one that is nice to deliver your code onto in the knowledge that everything has been taken care of from a platform perspective. There is less for you to worry about at the top level. Last on this slide is around access control. So access control, and in fact identity, is really, really key. And identity is the first step to securing your application, whether that's through authentication, logging into the application, or whether that's authorization, which determines what you can and cannot do within an application. Access control and identity is fundamental. And if you don't get identity right, that can lead to a number of different issues further down the line. Microsoft actually offer a leading number of identity services for both internal and external consumers of your application. So the B2B directories and the B2C directories in Azure Active Directory, as well as the ability to use internal accounts, mean that you can securely access applications that you develop and tie in identity models and authentication and authorization models to your application with ease, without having to maintain separate usernames, separate passwords, and separate role-based access profiles. So just moving on slightly, I want to now talk around what I like to call a DevSecops ratio. And the DevSecops ratio is really around highlighting the disparity between the number of developers and operations engineers within your organization versus the number of security experts that are within your organization as well. Now, my general rule would be that for every 100 developers and operational engineers and professionals within your organization, there is that one security expert. So everyone needs to be able to help with security. Imagine having 101 people in your organization that can comfortably identify and report security issues that need to be worked on within your applications. That's a really big selling point for any team and any organization to take advantage of. Now, we're not saying all 101 people have to be deep subject matter experts in security. A few need to be able to do that, absolutely. And you can hire professionals that do that. But just having people that in different parts of the cycle are able to identify any of those security concerns and flag them up to be dealt with is a really key benefit that your organization can take care of when it comes to DevSecops. So when it comes to security, not just the motion of DevSecops, but security in general, numbers matter within your organization. Okay, so when it comes to building DevSecops, there's 4 fundamental pillars that make this up. Now, a lot of DevSecops actually comes down to the culture of your organization and how you interact with the various different teams at play. So your developers, your security teams, and your operations teams. They have to be able to communicate and collaborate effectively together in meaningful ways that deliver meaningful results to be effective and to add appropriate value. Within the security function, I would generally expect to find these 4 areas. Now, these may be performed by the same people in some organizations that are certainly not large enough to warrant having separate teams. Some of these are also a bit more advanced as well, and we'll talk about them as we go through. So the first is around security engineering. So security engineering is really around The people that can take the application, can experiment with the application, build automation against that application to what test, go off and find out security holes. They're effectively your red team. Right? Your red team are there to go find holes in your application before the bad guys do. They're the ones that can save your organization and your application from a breach and ultimately save your organization from front page news. So that's something that's really, really important to take care of and important to note. The next is around security operations and your SOC team. So your security operations team are really the ones that can hunt, detect, and contain any outbreak within your organization. Any breach within your organization has the ability to run sideways and ultimately get to external parties as well. So it's your security operations team that effectively monitor and then contain any breaches that they identify. Next is around compliance operations. So whether it's GDPR, ISO 27001, you may even have PCI compliance. If you're in America, you may have HIPAA for healthcare information or ITAR for arms trading regulations. So compliance operations are there to be able to respond and manage those organizations that are responsible for those compliance operations and those compliance and regulatory frameworks when an outbreak happens. They are the ones that can help determine who needs to be notified of the breach. They can help determine the scope of the breach and determine how big of a problem this is actually going to be. So they can help manage those communication efforts while the security operations and engineering professionals are helping plug the security hole. After the fact, they can also then train staff as well. So a lot of organizations, in fact, most organizations in the UK should be doing annual security training around certainly GDPR and good data protection, as well as good security while using electronic equipment in the workplace. These are the teams that are responsible for running these compliance training schemes and operations and noting down attendance and being able to prove that to an auditor should they get asked for that information. The last one is a more advanced role, and you can liken this quite a lot to data engineering experts as well. So security science, so data science is where this comes to. They can take information from all of those previous three teams and they can put all of that data into models so that the team and the business as a whole can learn what is happening with their applications. They can model what is happening. They can measure the effects that would have on the application and the business, and they can help forecast what might be about to happen. That's really important to understand, and that's also really, really important to think about if you're a large organization with multiple different attack vectors into your systems. That is something that will help you understand and let you learn, measure, and forecast risk, and that's something that is really, really important. Next is around the journey to high fidelity feedback. Now it's a bit of a mouthful, high fidelity feedback. So what do we mean? Fundamentally, this is the process of being able to take sometimes billions of events or many events and put them into more tangible pieces of work for your developers to work on, or your developers' backlog. So this starts all the way on the left-hand side with your data sources. This is where you get your events from. So whether it is from internal or external security researchers, penetration testing, your internal red teams, it could be tooling that you have. It could even be indicators of compromise from previous events that have happened, generic logs or events, and even bug bounty schemes. Those data sources in large organizations can certainly generate billions of events. No one has the ability to sift through billions of events and look at those events and figure out which are the tangible things that our developers need to go fix. So we need to go through a process of automation. First of all, it's around correlation. If one configuration item is generating 600 alerts, for example, then don't have 600 tickets and 600 alerts. Have one with a parent-child based relationship so that you can see all of the data that's coming in if you need to, but you are responding to one security event. All of them together make one security event, not 600 security events with one security event. So base your incident and base your case or your ticket off that first one that comes through, and everything else underneath is ultimately secondary and is happening because of the initial event that has happened. Next is around case management. So we can start to go down from millions of events to thousands of events and reducing some of that noise by being more proactive on case management. We can use automation, we can use AI or machine learning patterns, or just general workflow-based management to be more proactive on the tickets that are raised as part of this process. Look for patterns. Can we relate any of those tickets to any other open tickets if this is a recurring incident that's happening? That is when in the ITIL world you will start to look at problem management and you start to create a problem ticket. So it's really important to make sure that you don't just open hundreds of cases for the same thing. Make sure that you can relate them together and, again, just like in the event side, have one ticket that you are working on and make sure you can collate everything together. What then comes out of case management are tangible things that the developers can then fix. These are tangible bugs that sit on the developer's backlog and have all of the intelligence and data they need to go highlight how this bug has been exploited, where this information has come from, what parameters did they use to exploit the bug, how many times is it happening, how severe is it. All of this is coming from the teams that we've mentioned previously. So it's really, really important to make sure that that information is all within your ticket history and is running through those automation processes all of the time to make sure that the information that comes out of there has a level of idempotency between incidents. It's no good having very detailed sets of information from one incident and almost no information from another incident. That's not going to get anyone anywhere. So high fidelity feedback is around taking potentially thousands, billions of events and getting them down into workable chunks of data, be that tens or hundreds, depending on the size of your organization. So next, I just want to go over into the technology side. And I want to talk about how Microsoft have enabled tooling to do this out of the box and provide a good story. Now, the scenario I want to go through is storing your code in GitHub and running through CI and CD, continuous integration and deployment pipelines to create container images, upload them into a container registry. You have secrets in your code as well. And you also have the ability to monitor through Azure Monitor as well. And this app also requires authentication through Azure AD as well. So some of the things that we've already talked about. So I want to talk about the 6 specific steps of tooling that can enable a really good, not only a good release and deployment story, but a good security story as well. So first of all, it's around GitHub. So GitHub, with some of its features like CodeQL or GitHub Advanced Security, and also tools like Dependabot, give you the ability to look inside the code that you've committed to your repository. You can remediate issues in any of your dependencies using automatic updates and patches, and you can also perform secret scanning. So when credentials are committed into source control by your developers, at the earliest point possible, you can capture the fact that those credentials have been committed to the repository and fix them before they go anywhere near the deployment and the pipeline process. That is a real fundamental journey to understand and capture the ability to do that and make your environment much more secure than it would be otherwise. Tie that into some of the other good software development lifecycle processes that you should be following around doing code reviews with your development team and doing spot checks or more detailed reviews. That can start to have a real impact on the security workflows that you have in place. Let's now move that along to pipelines. So in Azure DevOps and Azure Pipelines, we can build our container images with complete full traceability. So what do I mean by full traceability? Okay, that's a good question. This is the ability to look at all of your work items, all of your commits in source code, all of the artifacts that are pulled together in every single image, and be able to look at the release record that is created in the run of the pipeline and go back over time and say, whenever this ran, I know exactly what commits made this image. I know what work items were completed within this image as well. And I also know what additional artifacts were added in at build time as well. So being able to see all of that information gives you complete traceability all the way through. Add into that as well the fact that you are able to then deploy to numerous different locations and numerous different environments through pipelines. This makes it a really attractive thing to be able to do and a really nice story when it comes to deployment as well. So once we've deployed into the container registry, you can use integration with ACR into Security Center in Azure as well. Containers will then be automatically scanned for vulnerabilities. Anything that comes back as part of that process will be put into Azure Security Center. You could actually use integration with Security Center to then pull some of that information back and create bugs for your developers. They are tangible things that need fixing. There are links to CVE references that tell you what the exploit is, how it is being exploited in the wild, and what your risk factor is, and ultimately how to go about fixing it as well. So being able to interpret and understand that information is really key to making sure that your images that you deploy to your production instances are as secure as they can be. Just because they are individual container instances, don't fall into the trap of thinking you don't need the same rigorous approach to security as you would deploying any other piece of infrastructure. Container images are no different at all. Next is around Key Vault. So we touched on Key Vault a little bit earlier on. Key Vault gives you the ability to obviously ensure that any keys, connection strings, tokens, certificates, and any other type of secret are stored within a specific key vault. They can be HSM backed as well for additional security, so that your applications call them by reference at runtime. And it's a lot safer than including them in code. One of the great things I love about Key Vault is the ability to give application service principals the ability to call and access and read strings and tokens that are stored within Key Vault, so that you don't even have to have access as a developer. Once more, you can make this complete process 100% transparent by automating some of your setup processes. Automating your setup processes is incredibly important, because that means when you set up the resource, you can have automation that automatically generates passwords and puts them into Key Vault and returns the name of the secret. It is the name of the secret that developers then use to retrieve that secret in code. So even in development, whenever the development run is executed and built, even built locally or built in a staged production environment, all of those secrets are kept exactly that. They are kept secret. No one knows what the value of those secrets are. There is no higher level of security you can glean than being able to do that within your applications when it comes to secret management. Next is around Active Directory. So Azure AD, we've already talked about its class leading features when it comes to identity, but using some advanced features like multi-factor authentication, activity-based reporting, you could really go that one step further. So users may use things like conditional access to be able to get into applications from various locations. That might determine whether they have to use multi-factor authentication or whether they can log straight in. It might also do a number of different things as well. You can grant role-based access to roles within your applications within Azure AD as well. And on top of that, not just internal users, but also external users through B2B and B2C directories. You can invite external users or have external users sign up for your application and integrate with Active Directory. So Active Directory is a source of authority when it comes to user management and role-based access. Finally, as well, and tying it back into pipelines a little bit as well, having Azure Monitor look at both your applications via Application Insights and your infrastructure in near real time, tying all of that information back with quality gates and rollback-based monitoring means that you then have the ability to react automatically based on failures that occur after your deployment. If application insights starts to detect a number of error codes other than HTTP 200, you could instruct your pipeline to roll back the change that's been made to the last good configuration. And because we're keeping builds and deployments, that's an easy thing to do. And obviously with containers, that's a very quick process that happens as well if your containers are built and architected properly. So you can tie in with that monitoring data and automate your processes much further, meaning that all of the control really comes back to the developers who commit the code in the first place. That is why everything we've talked about in these 6 steps is fundamental, because if mistakes are going to happen, it is at the point they are committed to source control. So capturing them as early as possible, backed up by good processes and good tooling to be able to perform, high security requirements, is really, really fundamental when it comes to this. Okay, so I just want to now talk about some of the customers that I've worked with doing this kind of thing. So out of the teams I've worked with, when it comes to production, they report 30% fewer defects in production. So that's quite a big number. So if you think for every 100 defects that they log, that is 30 less that they are now getting. Now they have solid processes and less bugs coming through because of that. Mean time to resolution is now 5 times faster than it was before. I love mean time to resolution as a metric because for me it gives a better indication of how long it takes us to restore service. It is a much more meaningful metric as far as I'm concerned, rather than measuring platform availability via SLAs and percentages. As you move into cloud-based platforms where there is less and less within your control, measuring availability when there is so much out of your control doesn't seem as intuitive to me anymore, whereas MTTR feels like something that we have more control of to get the service back up and running. Last one on here is average success of CI and CD, so continuous integration and continuous deployment. Now this is a great metric to measure. Why is this related to security, I hear you ask? So again, that's a very good question, and the answer to it is actually pretty simple in a lot of ways. If you have a success of 98% in pipelines which have the ability to scan your code for vulnerabilities, scan your container images, scan your applications, do static code analysis and quality analysis checks and other compliance checks and tests, the fact that you are getting success and those are deploying all the way through integration and deployment indicates that those people, those developers and those teams involved are learning from that security shift left mentality. Because if they were, pipelines would be failing with all sorts of different errors because they weren't learning from the mistakes that they were making and they weren't learning to improve. A success of 98% shows that people are taking those things on board and are able to articulate back to you as a set of managers or a set of infrastructure engineers that we are taking this seriously. And look, you can see that we're taking this seriously because 98% of our pipeline runs finish successfully. So I want to leave you with 6 takeaways from the session. So first of all is don't measure at a team level. You have to measure globally. Implementing DevOps is all around removing silos. DevSecops is no different, just with the security wrap around it. But implementing DevOps is all around removing those silos and having people work in a more collaborative and communicative way. Security's goal is ultimately to help the business achieve goals, no matter what those goals are. So measuring at a team level rather than measuring globally, firstly, doesn't give a correct reflection and a correct picture of what's happening. Nor does it foster the kind of working relationships that you want between teams. It goes back to that level of siloed thinking. Next is around measuring outcomes versus outputs. Okay, so this is a whole quality versus quantity issue in a lot of ways. So measuring work is not tied to tangible outcomes, is what it says up there. And if we think about that for a second, we broadly, whatever we've been told throughout our career so far, it's not always about the quantity of work that you produce. It's about the quality. Make sure you have metrics that measure that exactly. The last thing you want to be doing is fostering a culture which pays people to deploy fast and fail hard. You certainly want people to fail fast and have that growth mindset, but make sure that you incentivize and prioritize the ability to measure those outcomes rather than the quantity of work that is produced. So number 3 is around maturity threshold. So maturity is absolutely important when it comes to DevOps and DevSecops, but it shouldn't be your top priority. So by all means, take your teams through maturity assessments that measure where they are and record down what they need to do to be better, but don't make maturity the be-all and end-all of the process. Prioritize the ability to resilience over that notion of security. Of maturity, and you will get much better progress as you go along. Okay, number 4, don't miss the forest for the trees. Focusing on individual components too much ultimately means that you end up missing the bigger picture. We're all guilty of this at some point throughout our career. We focus too much on a piece of work that needs doing, and it means that we miss the bigger picture. It's important to always see the bigger picture because that helps you drive where you need to be. So try never to get too focused on those individual components. Number 5 is around don't try to measure failure. So this is around what I was just saying around measuring SLAs and availability SLAs specifically as a percentage. Failure is inevitable. So incentivizing the avoidance of failure is an unrealistic measure. It's not a value-based measure to look at and report back. What is important, what is a key thing to look back on is how long did it take us to restore service? So this is back to MTTR again. And how are we improving that mean time to resolution over time? It's important to make sure that we improve that mean time to resolution, meaning that our outages are shorter. That demonstrates a mature understanding of the processes, the development processes, the operational processes, the software development lifecycle, and the application as a whole to be able to restore application service as quickly as possible. Lastly but not least, look on the inside. Right at the beginning of the session, we looked at data that showed the insider attacks are very, very common. So as much as your organization spends on protecting the edge of your organization and protecting people from coming in, don't forget to look at the people that are on the inside looking out. That is an important factor to put into your budgeting when it comes to security tooling and processes. Things like data loss prevention, encryption on your internal systems, and those kind of things are all important to making sure that builds up a really good story. So that wraps up the session. So first of all, thank you very much again to the organisers and sponsors. Thank you to everyone that has attended the session today. Much appreciate the time that you've spent listening to this. You can obviously catch me on social media or on the event platform if you have any questions or would like to discuss anything a little bit further. It's absolutely fine. Obviously, please reach out to me. Other than that, I hope everyone enjoys the rest of the day to start with, and hope you enjoy the rest of the sessions that are coming. So thank you and goodbye.